Hello, this is the third online class, which is going to deal with the linear ordinary differential equation. I hope that we can understand through this video the way of solving linear ordinary differential equation. Let's start. So first of all, this is what we call it linear differential equation or linear equation as an abbreviation. And then we're going to talk about the form of the linear differential equation. So what is the form that whenever we see it, we can say it is a first order linear differential equation. If we look to this equation here, we can call it a first order differential equation and linear in the same time. So first order differential equation is linear if it has the form, as you can see, this is the form, which is the derivative or y prime. Okay, so we are going to say that we have y prime plus a function of x, p of x, times the function itself. So the first derivative of the function plus a function of x times the function again equals to another function of x. So this is the form of the linear differential equation. From here you can see that we have like the first derivative here as if we have the no derivative here, and then this is the right hand side is going to be a function of x. If we could find this form in any differential ordinary differential equation, in this case we are going to put some solution procedure, okay, a solution procedure to proceed with the solution. Okay, so this is the form. Remember, whenever we have this y prime here, okay, in a separate term, and there is a function of x multiplied by the function y itself, and the right hand side is going to be y or q of x. Okay. There is a general solution for solving the linear equation, which is going to be primarily depends on what we call it the integrating factor. Let's go with this. So first of all, let's assume that we have g of x equals to e to the integration of p of x dx. This is the first assumption. Remember that we are already defined p of x before. Okay, so if we go back, you're going to find this b of x, this p of x is multiplied by y. So if we could find this function of x, which is multiplied by y, and we integrate it in the power of the exponential form, we are going to allocate it to a function called g of x. So notice that the first derivative of this g of x, the first derivative, is going to be g prime of x equals to p of x. We're going to bring this power down, and then e to the integration of p of x dx. If you look deeper to this, here, it is what? E to the integration of px of dx. It is what? It is g of x. Then we are going to have p of x times g of x. The derivative of a function, which we started to put it as e to the integration p of x dx, the derivative of it equals to p of x times g of x. Okay, now we are going to multiply, okay, the whole function or the whole equation with this integrating factor, okay? I mean that the integrating factor that we have obtained here, and this is our equation. Okay, so we're going to multiply this equation by g of x. So we're going to obtain g of x times y prime plus p of x times g of x times y. This is okay, equals to q of x times g of x. Okay, in view of equation 1.3, which is this one, we can put our function, this g of x y prime plus g prime of x, take care, this is g prime of x, that already we have times y, which is equal to P of x, G of x, right? This is G prime of x. Okay, so now for this, we are going to find this is times y, and then we are going to multiply q, or equals to q of x times g of x. Now we see that the point here is very clear. If you look to this left-hand side, it is what? Actually, it is as if that we are making the derivation by chain rule of d by dx of something, or a function called g of x times y, right? Because here g of x is going to be derived once, okay? So it is going to give us like g prime of x here times y, and y is going to be derived 1, and the other function would be intact, so y prime times g of x. Then this is what we call it equal to the derivation of the function g of x that we have assumed in the beginning times y, right? So this is, remember that g of x, we have assumed it from the beginning. We are going to call it the integration factor, or the integrating factor, okay? Then this would assume the steps of the solution for us, which is we are going to end up with, this is the way of how we are going to solve our equation, okay, or our differential equation. Now let's go through a sorted steps to understand the procedure clearly. So if we ended up with this, so starting with assuming a function, this function takes the p of x as the power of the integration for the exponential function, and then we are going to multiply this one, or this function, in the original differential equation. After multiplication, we found that the left-hand side is the derivative of this assumed function, which is g of x, times the original one, which is y. And the right-hand side, it is q of x, already we know, times g of x, that already we have assumed. Based on this, we can integrate, we are going to integrate both sides. So if we go back, this side's d by dx. If we put the integration here, then it would cancel this part, and g of x, y would be the remaining, g of x, y, equals to the integration of q x gx dx plus the integration constant. If we are going to assume that g of x, which we have already obtained, it does not equal to 0, we can solve this equation for y as y of x equal to 1 over g of x, the integration of qx gx dx, plus the constant over g of x. This is the general solution with the arbitrary constant c, okay? This is what we are going to follow. Actually, it is super easy if we're going to have an example, okay? Because you need not to understand or to memorize all the steps here in detail, but you need to memorize something. First thing is, this is the first thing, which is try to find the integrating function and then multiply it by the original ordinary differential equation, and then integrate, this is number 3, which is the integration, then make the final general solution in terms of y. Okay, this is the main steps that we are going to follow. Let's go here to these main steps and just report them in some wording to remember it. So if the differential equation is linear, we need to have this form first. Remember that this is the linear form. This is the linear form. As we said, y prime only, and here there is y, and then we have a function of x multiplied by y, and in the right hand side another function of x. Okay, then we are going to compute this. We are going to call this the integrating factor. Integrating factor, okay? E to the power integration of p of x dx. This is step number 1. Step number 2, multiply the differential equation by the integrating factor. So we are going to use our integrating factor, okay, p of x here, dx, and we are going to multiply in the original differential equation, the original or the ordinary differential equation. And number 3, write the left side of the resulting equation as the derivative of the product of y and the integrating factor. This is what we are going to have. Okay, so it would be, this means that it is d by dx, whatever the integrating factor is, okay, p of x dx times y. This is what we are going to put it. Then integrate both sides of the equation. This is step number 4. And solve the resulting equation for y, obtaining the general solution. Okay, so this is something, these are the main 4 steps. Now let's jump into examples to know and to see how the procedure is going to be followed. Okay, now let's go with this example. Let's have that we have an equation, ordinary differential equation, y prime plus y equals 2x is linear with, where is px here? Yes, px is here, it is 1 here. So px equal to 1. And qx equal to x. This is the right hand side. So we have px and we have qx. The integrating factor is going to be, yes, e to the power px dx equals to e to the power 1 dx, which is ex. So our integrating factor, this is going to be our integrating factor. Multiply the differential equation by this integrating factor, which is e to x. This is our differential equation. E to x times y prime plus e to x times y equal to x times e to x. This is the ordinary differential equation after being multiplied. This means what? If you look to here, the right hand side, exy prime plus exy. This means, yes, it is the derivative of the multiplication of the original function y times e to x. And this equals to x e to x, which is the right hand side as it is. Okay. Then integrate this equation. Actually, this, the left hand side, it is as if d by dx of y e x. So whenever that we are going to put the integration would remove this. So we are going to end up with e times e to x equals to the integration of xe to x times dx, as you can see here, and this would equal to what? Exactly integration. This is the integration of xe to x. We can use the integration by parts, which is x e to x minus e to x plus a constant here. Finally, we can solve this equation, okay? Because we have here e to x multiplied by y, then we are going to multiply it by e to minus x, then we are going to find the left-hand side is y, the right-hand side is going to be x minus 1 plus ce to minus x. This is the general solution, okay, containing an arbitrary constant. This is the general solution and containing an arbitrary constant, which is c. Okay, so this is simply this is how it goes for our case. Let's go and have another example that is going to make it easier for us. Okay, here another example. Another example here, which is solve this initial value problem. So we have IVP, which is initial value problem. Y prime equals to 3x squared minus y over x, where y of 1 equal to 5. So the independent variable equal 1 and the dependent variable equals to 5. This differential equation is not linear. If you look to it, it's not linear in terms of its arrangement in this form. So we're going to put it in a form that is going to be linear, which is what? We're going to put y prime here plus 1 over x times y equals to exactly 3x squared. This is linear form for us. Now we can deal with this form, which is this form here. Okay. which is linear. Now this is a linear form. So the integration factor here is what? Exactly e to, yes, 1 over x dx. This is our p of x here, so we put it here, which is this one. Fortunately, e to ln x, 1 over x, means that the integration of 1 over x, which is ln x, then it equals to x. For x larger than 0, which is positive, because we're talking about the natural logarithm here, multiply the differential equation by the integrating factor x. This is the ordinary differential equation. We are going to multiply both sides. I'm sorry, this is the one after being linear. So xy prime plus y equals to 3x to the power 3. Now, if you look to this, yes, it is as if the derivation by chain rule, x times y, right? Derivative of x. This is as if it is d by dx to x y equals to, yes, 3x to the power 3. Then, based on this, we can take the integration of both sides. So the integration is going to end up with xy equal to the integration of 3x cubed. Super simple integration. We can integrate it easily. So we are going to integrate xy equals to 3 over 4 x to the power 4 plus an arbitrary constant of the integration. Then we're going to solve for y to have an explicit solution. Then we're going to put this x in the right hand side. So we can obtain y equal to 3 over 4 x to the power 3 plus c over x. For the positive values of x, the initial condition we need now here, we want to get this value of c. How we can obtain it? We can obtain it by using the initial value. Remember that we have x1 and y equal to 5. This is from the initial conditions. Then y of 1 equal to 3 over 4 plus c equals to 5. That's right. From here we can obtain c equal to 17 over 4. And the final general solution of this initial value problem is going to be y equal to 3 over 4 x to the power x cubed plus 17 over 4x. This is our general solution. This is our general solution. Okay, now I hope that these two examples would explain it very well for you. We are going to we are going into deeper or more examples to make it easier for you to follow. Okay, now let's go through these 5 examples together. And as I said, this supposedly to be like in-class assignments, so you can stop the video at this moment and then try to work out these examples by yourself. Okay, the 5 examples. Okay, so this is strongly recommended for you to do it by yourself to check your ability after understanding the 2 examples or the 2 previous examples that I have explained. Now stop the video and try to solve it by yourself. Okay. Now, if you solved it, okay, and you already have your results with you, then you are going to look to what I'm doing here. Let's go with the first one, which is y prime minus 3 over x times y equal to 2x squared. This is, as you can see, seemingly to be a linear equation because we have y prime here, we have y here, this is p of x, and this is q of x, so it is perfect linear ordinary differential equation. Let's show how we can solve it. So this is y prime, this is the equation, this is the linear equation as we said. So where is p of x? P of x equal to exactly minus 3 over x, which is this one, exactly. And the integrating factor is going to be e to the integration of p of x dx, which is e to minus 3 ln x, which is equal to x to the power minus 3. This is the integrating factor. This is the integrating factor. So number 1. So first thing is to get the integrating factor. This is number 1. Then multiply the differential equation by our integrating factor. We are going to obtain after multiplication, so we're going to multiply This is our differential equation, y prime minus 3 over x y. Okay, this is the left-hand side times x to the power 3. Okay, and the right-hand side is going to equal to 2x squared times x to minus 3. Let's go with the left-hand side now to be sure that it's really equal to what we are expecting. Y prime times x to minus 3 over x y times x to the power 3 equals to y prime x minus 3 over x to the power 4 y. If you look to this deeper, you can say that it equals to d by dxy times x to minus 3. Okay, so now we are having this in the left-hand side. And the right-hand side, it's supposedly to be multiplied by x to the minus 3. So it is going to be 2 over x. That's right. And then a routine integration gives we are going to integrate. So the second step for us, we are going to integrate this. The integration of this differential equation gives us yx to the power 3. And in the left-hand side is going to be 2 ln x plus a constant. Okay, so this constant is an arbitrary constant. Then we can end up with our general solution for our equation, which is y equal to c x to the power 3 plus 2x cubed ln x, where x it is positive value always. Okay, so this is what we can call it the general, this is our general solution. Okay, so again, if you go through the steps, you're going to find it easy. First, put your equation in the linear form. Already in our example, fortunately, it was already arranged in a linear form. Then we need to find the integrating factor. And after that, we are going to multiply the integrating factor in the differential equation and then integrate them. And then we are going to find the general solution. Okay, I hope that it is similar to what you were doing by yourself. Let's jump into the second example and see how we can solve. So let's have a look first on the example. It is y prime plus y equal to half times e to x minus e to minus x. I think that it is in the linear form. We have y prime and y. If you look here, we're going to have that p of x equals to exactly 1. Because here it is as if that we have 1 here. So our integrating factor is going to be e to the integration of 1. So it is going to be e to x. This is our integration factor, or the integrating factor. Then we're going to multiply the differential equation by e to x. We're going to obtain, this is the left-hand side, y prime e to x plus y e to x equals to y times e to x. Actually, this is as if the derivative of two functions multiplied by one another, y times e to x. So commonly you can do it like this directly. Your function, which is y, times the integrating factor, okay, prime. That's it. So no need to like multiply every time and see. No need to make this step. If it is linear form, then automatically, if you are going to use the right integrating factor, it is going to be like this for you. Equals to half times e to 2x minus 1, because we multiplied the right-hand side with e to x. So this is the right-hand side. Then we are going to integrate. Our integration here, this one goes to y to x. And the right-hand side is going to be e to 2x is going to be 2 here, and there is another 2, so it's 4 here. E to 2x, the same exponential function, minus half x plus a constant here, which is c. Then our final general solution, this is the general solution, okay? It is quarter e to x, because we have e to x here, we're going to multiply all the function by e to minus x, okay, all the equation. Then we have y 1 over 4e to x minus half x to e minus x plus ce to minus x. This is our final general solution. Okay, Okay, I hope that you are getting better in terms of the problem solving skills for the linear differential equation. Let's go to the third one. Okay, you are going to find that having numerous examples and problems going to master the techniques of solving for you. So that's the key here for mathematics. Solve numerous examples and problems and you're going to find yourself as a master in mathematics. That's it. Okay. Okay, let's go to this. This is another linear one here. Y prime plus 2y equal to x. I can hear you saying that our p of x equal to exactly 2, and the integrating factor is going to be e to 2 dx, which is e to x directly. Okay. Okay, this is the integrating factor, and we're going to multiply it by the differential equation. This is our differential equation, y prime times e to 2x, 2y times e to 2x. Okay, this is y prime. Multiply the differential equation by the e to tx to obtain. So it is y prime here, e to 2x plus the 2y. Supposedly here there should be e, yes, to 2x, I think. It has been missed here. So based on this, you are going to find yourself. This is the derivative of y, that's right, y times e to 2x. If you are going to use the chain rule, then you are going to find that it gives y prime e to tx plus 2. Yes, that's right. We should put it actually first here. So e to 2x, it should be here. Okay, and then we are going to end up with, this is x. Okay, to obtain, and here in the right hand side is going to be x times e to 2x. Then here we're going to end up with, this is the derivative of the multiplication of the two functions. If we're going to integrate, then we're going to have the inner part, y e to 2x equal to the integration of the right hand side, x e to 2x times dx, and this equals to half x e to 2x minus 1/4 e to 2x plus c. That's right, because this is the integration here that we are having, integration by parts. It would yield for you this right hand side. Then still we have some function of x here. We want to through it in the right hand side. So the general solution is going to be y, after we multiply by e to minus 2x here, we can obtain this, which is half x minus 1/4, half x exactly minus 1/4 only, because this would be 1c e to minus 2x. That's right, and this is our general solution. Okay, I hope that you could understand this. Let's go to the fourth one. Let's go to the fourth one. Okay. Let's see. Okay, number 4. It is y prime plus sec x y cosine x in the right hand side. As you can see here, our eyes goes directly to this. So our p of x here is going to be sec x. That's right. And the integrating factor is going to be, as you can see, e to the integration of sec x dx, which equals to e to ln. Remember that sec x means the integrating of sec x, which is the ln of sec x plus tan x. This would equal to, this is the natural logarithm also for the same base. So sec x plus tan x would be the integrating factor for us. Multiplying the differential equation by this integrating factor, we are going to obtain here y prime times sec plus tan, and here we have sec plus tan times sec square x times y. This is y here, and we are going to multiply sec. So we are going to have sec tan and here sec square, that's right, equals to, we're going to rearrange them. Okay, We're going to rearrange them. If you look to them, they are the derivative of dy dx for what? Exactly y, and the other one is going to be sec x plus tan x. This is the derivative that we are having. This is one function and this is another function, okay, which is here. This is one function, this is another function, and this is the derivative sine, which is equals to cosine x times sec x plus tan x. Okay, if you are going to make this the arrangement, because we have here cosine x in the right hand side, cosine x times sec x tan x, this is the integrating factor, this is the right hand side of the original ordinary differential equations. So we are going to end up with 1 plus sine x, 1 plus sine x, cosine sec multiplication 1, and here cosine times tan, it is sine. Okay, so this is the form that we can use here, and then by integrating this equation we are going to find y sec plus tan equal to, yes, the right hand side is going to be x. Remember, the right hand side is 1 sine x here, so it is x, yes, minus cosine, this is the integration, plus a constant factor here which is x. Multiply both sides of this equation by, yes, because we have, we want the inverse or the reciprocal of sec x plus tan x. We're going to multiply it by both sides. We're going to obtain 1 over sec plus tan equals to cosine x over 1 plus sine x. Then we are going to have in the left hand side, after getting rid of this term by multiplying by 1 over this term, okay, then we're going to end up with x minus cosine x plus k times, yes, this term, which is the inverse or the reciprocal of sec plus tan. Then y is going to be this nice fraction x cosine x minus cosine squared x plus k cosine x over 1 plus sine x. This is the general solution of our equation. Okay, so we have used a great deal of trigonometry functions, but at the end we can get our final general solution. Okay, let's go to the final one, or fifth example. So in this example, if you look, we have, yes, y prime minus 2y, our p of x, as you can see, equals to minus 2, that's true, and this is the right hand side, minus 8x squared. So the integration factor is going to be exactly e to the integration minus 2 dx, which is e to minus 2x. Multiply the differential equation by this integrating factor. We have y prime here times e to minus 2x minus 2y times e to minus 2x. Then we're going to find that it is, if you look deeper here, it is as if it is the function d by dx of y times e to minus 2x. Yes, that's right. We put it here. And this is the right hand side after being multiplied by our integrating factor. So after integration, we are going to obtain, this is here, integration would cancel this. So we are going to find y e to minus x equals to the integration of the right hand side here, dx, which is this form. Integration, this is a simple integration for you. It is going to yield this 4 terms, 4x squared e to minus 2x plus 4xe minus 2x plus e2, or 2e minus 2x plus a constant, and then the general solution is going to be this one, 4x squared plus 4x plus 2 plus ce 2x. This is the general solution. I hope by this 5 examples already, now let's go to it. Yes, these are the 5 examples. I want you, again, after finishing the video, if you have some mistakes before watching this portion of the video, then you should rectify yourself and try to think about what was the error or the mistake that you've done and rectify it, and then try to solve it again. Okay, so this is a very good practice for you to master the skill of solving the linear ordinary differential equations. I hope that this would be good for you, and you have mastered now linear differential equation through numerous examples and explanation of the main idea. Thank you, and see you in the next video.